Let's proceed to model this enclosure as seen in this picture. The enclosure is a combination of two rectangles as seen from this view. All the sharp edges are filleted. This model has a base frame with holes and stiffeners. The model is hollow from inside, so we apply a thickness after creating the surfaces. We will have to switch between part design and shape design workbenches for this model as well. Let's start the design. Let's take a look at this slide. In this step, I will start a new part. Draw this sketch and constrain it. I will use the centered rectangle command to draw two rectangles, and then use the corner command to smoothen the sharp corners on one side of the profile. I will use the 3D profile command to make this profile visible even when the sketch is hidden. In the CATIA window, I will start a new part and name it Exercise 2. I will rename this geometrical set to Top Sketch. As usual, I will create a point at the center and then start a position sketch. I will draw the sketch as seen in the picture below. I will first use the centered rectangle command and draw two rectangles. After constraining the dimensions, I will apply the corner feature on one side of the profile as shown. Let's make this profile as 3D profile. In the next step, I will draw the sketch of the front view section of the model. I will use centered rectangle and circle commands to make this sketch. Then I will convert this sketch to a 3D profile. I will first insert a new geometrical set and rename it as Section Sketch. Next, I will start a position sketch on the XY plane and align the V and H directions axes like so. First, I will draw a horizontal axis passing through the origin. Next, I will draw a centered rectangle. Let's constrain this rectangle as seen in the picture below. I will draw a circle tangent to the top horizontal line of the rectangle. with the center coinciding with the V direction axis. I will constrain this circle radius and then use the quick trim command to remove unwanted edges. The sketch is now fully done. In this next step, I will extrude the 3D profiles of the sketches and trim the unwanted surfaces. I will use the sphere command to create the curved surface as seen in this picture. Let's look back in the CATIA window. So, first I will activate the Generative Shape Design workbench. Next, I will define the top sketch as the work object and perform extrude command on this 3D profile. I will let the extrude dimensions be more than the actual height of the body. Next, let's define the section as the work object and extrude the sketch underneath. I will let the extrude dimension for this profile also to be more than necessary, as I am going to trim off the extra surfaces. Now, I will click on the trim command from the operations toolbar. I will select both the extrudes and alter the surfaces to be trimmed like so. I can click on the OK button to complete this operation. The desired output is obtained. Let me apply the edge fillet operation on the corners of the surfaces as shown. Now I want to draw a sphere to verify something. In order to use the same center point for the sphere as that of the circle from the previous sketch, I will edit that sketch and convert this point into a 3D profile. You know why, right? This point is now visible even after I exit the sketch. Next, from the Surfaces toolbar, I will select the Sphere command. I will now click on the Center Point 3D profile for the center field in the Sphere Surface Definition window. Let's update the sphere radius to 250 mm. And under Sphere Limitations, I will click on the Create the Whole Sphere button. I will click on OK to exit this window. What difference do you see now? The curvature obtained by the sphere is not the same as that obtained by the extruded profile. The sphere curvature is in all directions, while the surface extrusion curvature is only along one plane. So, I will use this sphere to create the top surface of the model. Instead of the previous sketch extrusion, I will right-click on the Extrude To in the specification tree, and then click on the Replace option. Let's replace this Extrude To with the sphere surface. If I double-click on the Trim feature in the specification tree, I can see that Extrude To is already replaced by the sphere. I will alter the trim surfaces for Extrude 1. You can see that the grayed out surfaces have now switched. So, I can click on OK to confirm this operation. The surface model is now updated. I can use the Delete Useless Elements command from the Tools menu bar to delete the unwanted features. This table lists all the possible elements that can be deleted. You may change the status of one or more elements and click on OK to delete the selected elements. Moving further, in the next step, I will draw this sketch of the base frame using the existing sketch. I will use the commands you see in this slide. In the CATIA window, I will first hide the 3D profiles and define the top sketch as my work object. I will start a new position sketch on YZ plane. I will use the Project 3D Silhouette Edges command from the Operation toolbar and get the outer profile of the surface model as shown. Now, let me constrain the profile to make it fully defined. Now, I will draw the circles as shown and constrain them. The small circle radius is 6 mm. And outer circle radius is 15 mm. I will use the mirror command to copy these circles onto the other side of the V direction axis. Let's trim off these extra lines as well. I will also draw a horizontal line passing through the origin as shown. Let me convert these lines into 3D profiles. I will use the Via Automatic Propagation option for this profile. Next, if I select all the circles and try to create one 3D profile, CATIA throws an error as they are not continuous. So I can convert these circles to 3D profiles separately. But for now, I will not make them into 3D profiles. The sketch is now completed. In the next step, I will extrude a flat surface using the horizontal line 3D profile and also extrude the base frame profile. I will split and trim the surfaces to form the surface shown in this picture. To begin with, I will extrude this horizontal line normal to XY plane as shown. Let me also extrude the base frame profile normal to YZ plane as shown. Now I will click on the split command from the operations toolbar. For the element to cut field, I will select the flat surface like so. And for the cutting elements field, I will select the outer base frame extrusion surface. I will click on the other side button to split the correct side of the surface. And click on OK to complete the split operation. The surface model seems to be correct, but the bottom side is still not hollow. To get the hollow part of the model, let's apply a trim command. In the trim definition window, I will select the split 1 command and the edge fillet 2 feature from the top sketch geometrical set. Let's alter the side of split 1. Once I click on OK, you can see that the base is trimmed off at the center to form the hollow surface. I will change the color of the model from the Graphics Properties toolbar. This step is now completed. Since we have one surface for the entire model, in this next step, I will walk you through thickening this surface. This step will convert the zero thickness surface into a solid model. Then I will add holes as seen in the picture using the pocket feature. Next, I will smoothen the sharp corners using the edge fillet command. Finally, I will add stiffeners on 3 sides of the body to add strength. The thick surface command is available in the part design workbench. So, let me activate the part design workbench. I will also define the part body as my work object. Now, I will select the thick surface command from the surface based features toolbar. With first offset value as 5 mm and object to offset as trim 2. I will click on reverse direction and then click on OK to complete this feature. Next, I will apply edge fillet on the edges as shown. I will apply 20 mm radius on these edges. And 10 mm radius on these 4 edges. Next, I will start the pocket command from the sketch-based features toolbar. Let's hide the surface and 3D profiles of the model as shown. I will select the holes from the previous sketch for the profile field, reverse direction of the pocket if required, and then click on OK. I will now add fillets of radius 3 mm on the top and bottom of the enclosure as shown. Lastly, I will add stiffeners to complete this model. Stiffeners and ribs give strength to solid bodies and avoid deformations. You must have observed stiffeners on beams of bridges. This is to strengthen the member, and we'll be doing the same for our model as well. On the XY plane, I will start a sketch and draw a line as shown. I will constrain this line at an angle of 75 degrees with the YZ plane. And a vertical dimension of 15 mm. I will add a coincidence constraint between the top end of this line and the surface of the model as shown. I will click on the stiffener command in the sketch-based features toolbar. The sketch is already selected for the profile field. I will update the thickness 1 value to 5 mm. Once I click on OK, a stiffener is added to the model. I will apply a mirror feature to copy this stiffener onto the other side of the model along the ZX plane. Let me create another stiffener behind the model. My sketch is on the ZX plane this time. With this, all the steps pertaining to the solid model in this exercise are completed. Let's move on to the next step to make the drawing of this model as seen in this picture. I will add a front view as seen in the bottom left side of the picture. With the projection view command, I will place the bottom view. Then, using the section line on the front view, I will create a section view. I will also create a detail view cutout of one of the section views. Finally, I will insert these two isometric views, which shows all the details of the model. Next, using the dimensioning toolbar commands, I will place all the required dimensions as shown in this picture. From the Start menu, I will click on Mechanical Design and then click on the Drafting workbench. I will select Empty Sheet and then click on OK. A new empty drawing sheet opens up. Now, I will click on the Front View command in the Views toolbar and switch the window to the solid model of this exercise. I will place the front view as shown using the Views option and then click on the base. Next, I will add a projected view as shown. Now, let's add a section view. I will draw the vertical section line as shown and place the section view beside the front view. Let me also add a detail view as shown. I will edit the properties of this view to show the center line. Next, I will select the Dimensions command from the Dimensioning toolbar and add all the linear dimensions in this view. Next up, I will select the Radius Dimensions command and add them like so. Let's update the name of this view to Top View. Let's move on to adding dimensions on the bottom view. I will add the linear dimension as shown and then the radius dimensions. I will update the view name to Front View. For the detail view, I will add the linear dimensions first, and then the angle and radius dimensions as shown. Now, I will click on the isometric view on the Views toolbar, then switch to the Model window. I will place the isometric view in the Graphics area using the Views feature and click on the flat surface as shown. The isometric view appears in the drawing as seen. Once I click on the outside of the view is confirmed. Similarly, I will bring in the other side of the isometric view like so. The drawing is now completed. I hope you got some idea on how to use the commands required for surface modeling. There are many more advanced features that can be used for surfacing. We shall discuss them in an advanced course session. In this course, we have covered basics required for topics in CATIA V5 like sketching, part design, drafting, assembly design, and surface design. I hope that the exercise that I walked you through and the challenges that you would have practiced gave you a good understanding of the software. You are now ready to design any product while exploring more commands and capabilities of CATIA V5 as you keep using the tool. Using this knowledge, you can apply the tool in any manufacturing engineering sector to create 3D CAD models and their drawings. You may refer to our website to learn about other courses related to CATIA. Thank you for watching. Have a great day and all the best.